Welcome to Brain Vision.
So we have an aluminum cylinder of radius 0.41 meter and mass 28.4 kilograms, rotating about its axis. And the temperature changes from 20 degrees Celsius to 95 degrees Celsius. We want to see the fractional change in the angular speed omega. So why would the angular speed change? It would change because when the temperature would increase, the radius of the cylinder would increase, increasing its moment of inertia, and because of conservation of angular momentum, the omega value would decrease. So for that, let's find the change in angular momentum. Moment of inertia. We know that initial angular momentum is equal to final angular momentum, which will give us I naught omega naught is equal to IF omega F, which gives us final omega is equal to I naught omega naught by final inertia. We know that for a cylinder, inertia is half m r squared, which means it is half m r naught squared times omega naught by half m r squared, which gives us r naught by r square whole squared times omega naught. We know that r is r naught times 1 plus alpha delta t, which gives us omega f is equal to omega naught by 1 plus alpha delta t whole squared. Now we only want to find the fractional change in omega, and we know that fractional change in omega is final omega minus initial omega divided by initial omega. So that final minus initial, so that's 1 by omega times omega naught by 1 plus alpha delta t whole squared minus omega naught, which is 1 by 1 plus alpha delta t squared minus 1. Now this is simply minus 2 alpha delta t plus minus delta t times alpha whole squared divided by 1 plus alpha delta t whole squared. Now because alpha delta t is very small, we'll ignore this term and we'll ignore this term within the summation, giving us minus 2 alpha delta t. So in our case, that is minus 2 times alpha is 25 into 10 power minus 6 times delta t is 75 degrees Celsius, giving us minus 3.8 into 10 power minus 3, which is about 0.38% decrease.